already I have uploaded today's class note and also one assignment sheet. So today I will discuss on the class note which I have already uploaded, and then we will try to solve problems given in the assignment. So I hope you have gone through the notes at least once. Let me share it. So this is what I have uploaded, and hope you recall that in the last class which we had on transportation planning, we talked about the need of having appropriate transport plan, and also we understood that at the beginning we have to take certain steps which would help us to identify whether we should have long-term or short-term solutions to get rid of scenario. And then we understood that if we understand short-range solutions would work, we can go with some solutions mostly traffic management oriented. Otherwise, if we understand that these solutions will not be effective for considerable time, in that case we have to start thinking at the future. And in doing so, what we need to do, we need to go with something called 4-step modeling. And in transportation planning, this 4-step modeling is very well known and very popular and also very effective. What we do in the 4-step modeling, we start with something called trip generation, and then we move on to the next step, which is trip distribution, and then finally we have to understand modal choice of commuters, and then finally route for traffic and transit. So this is what we do in the process of modeling. But before we start making such model, it is very imperative for us to understand the area of the city for which we are going to make a plan. Last day we discussed that we have to draw the cordon line. Whenever we are demarcating the cordon line, we have to understand one thing, that if we consider only the current city limit, it may not be valid 10 years, 15 years, 20 years, 30 years down the line. Why? Because city may expand, and in future it may have some other developments in its fringe areas, and fringe area may act as density. At that point of time, what will happen? Our plan, whatever we make, will not work. So therefore, while identifying the cordon or external cordon which will be acting as city limit in future, we have to consider all future developments. And last day we discussed that suppose currently we have an area adjacent to the city which is being used for the purpose of agriculture. It may so happen that in future that particular land may be used for institutional purpose, for residential purpose, even for industrial purpose. You never know. So you have to visit to the concerned department who are involved in making such plans, and you must get to know what kind of plan they have for next many years to come. And accordingly, based on their plans, you will have to include those areas that are having potential to grow in near future. Not only that, today whenever we are making plan, we have to take all regular trips into account. Suppose we are making plan for a city and we get significant number of regular trips that are not being generated in the city, that are being generated from a place that are outside the city. In that case, what we have to do while making a new plan, we have to include those areas, given the fact that we are having significant amount of trips from those areas, right? So this is what we do while identifying the external cordon. After we identify the external burden, we get the limit for which we are supposed to make a plan. Then what we have to do? We have to divide the entire area into number of parts, because entire area will have different land use. Somewhere land use may be residential, somewhere it may be institutional, somewhere it may be commercial, somewhere it may be mixed. So you have heterogeneity in the use of land use, in land use pattern. So keeping that point in mind, what you have to do, you have to make zones. And while making zones, you have to follow certain norms. Last day we understood that we have to start with identifying the central area or central business district. Once we identify central business district, we have to divide the entire area into number of sectors. This term sector is very well known to you. You all understand what sector is. So initially what we do, we divide the entire area into number of sectors. And you understand that sectors will be large enough to deal with. Therefore, what you have to do, you have to again divide each and every sector into number of zones and if needed into subzones. So once you have divided into number of zones or subzones, then what you will be doing for each and every zone, you will be developing trip generation model. What is that? Trip generation model will indicate the potential of that area to generate trips. Last day we took one example that if we consider IIST Sikpur campus as a zone, you will see that in the morning it has huge attraction potential, and in the evening it has huge production potential. Right? So similarly, each and every area, every zone will have some production and attraction potential which we need to capture. So you understand that production or attraction, which we call as trip generation, will depend on certain attributes. And the very first attribute is population. If you have more population, there are possibilities that you can get more number of trips. And in addition to population, we also have to understand that there are certain other factors that play a significant role, like employment. If we have employment, there are possibilities to get more number of trips. Right? Also, we will have to take into account some other factors like what kind of employment and also school-going children. So those things will be acting as an attribute while developing a trip generation model. So the very preferred modeling technique for trip generation is regression, multiple linear regression. So there are some other modeling techniques also. I'm not going into those techniques. Multiple linear regression is very well adapted technique worldwide. What we do here, we consider number of attributes, and those attributes are brought under single umbrella by way of regression. Right? So then we get trip production model and also trip production model for each and every zone, whatever we have in the area within the quarter line. So now the next task is very, very significant. Next task is what? Now we need to understand the interchange of trips between any two zones. Suppose you have zone I and zone J, any two zones, zone I and zone J. You have to now determine the trip interchange between zone I and zone J for today, for tomorrow, and also for day after tomorrow. Right? Up to the horizon year for which we are making our plan. This is going to be very, very critical because what this you will have to depend on household data. Last day we understood when we talked about different types of trip like internal trips, internal external trip, external internal, and also external trips. We learned different techniques by which we can deal with those trips. I hope you remember that for external trips, we learned that providing a bypass could have been the best possible solution. Similarly, if we are dealing with internal trips, it's very critical and it's very difficult to capture because here we have to rely only on secondary household data. We have to take some responses from different households, and based on their responses, we are going to develop such tree production and production. Okay. So now in this process of determining trip interchange between any two zone Y and J, what we'll be doing, we will be trying to develop an effective model. You understand one thing, that trip between any two zones will of course depend on the attractiveness. Let me clarify this part. Suppose you need to make a trip for shopping. Suppose today you have decided to make a trip for shopping, and you have also decided that for shopping you would like to visit to a shopping mall. So now what we will do, we will identify some of the shopping malls in the city where you can visit. Suppose you have identified two shopping malls. One is Avani, which is very near to your hostel, and another one is, say, South City Mall, which is near Jadavpur University. So you have decided to go for shopping, and you have two options, two possible options. One is Avani, and other one is South City Mall near Jadavpur. So now attractiveness is what? Attractiveness is something which is eventually expressed in terms of impedance which will be offered between these two zones. Now you understand that these two zones, your IIST Sirpur campus and the zone where Avani Mall is and the zone where South City Mall is, there will be some spatial separation. So your trip will depend on the distance that you have between your place of residence and the place where you would like to visit. So distance would play an important role. If distance is very large, you may not make that trip. And also, not only distance, suppose you know that, suppose let us assume that those South City Mall is, distance between your place and South City Mall is larger compared to Avani Mall, but these two places are connected by metro. And you know that if you go by metro, you will have to spend less amount of time. So you may be interested. So distance will be expressed in terms of spatial separation and also in terms of time. Not only that, you will have other factors like out-of-pocket cost into account. So altogether, taking these things into account, you will identify what? You will identify the impedance between the places where you would like to make the trip. Okay. So trip making possibility between two zones I and J would depend on attractiveness of that area where you would like to make that. Suppose South City Mall and Avani Mall, you will compare where you are going to get better facility and where exactly you are going to get the things which you would like to purchase, right? So attractiveness of that area will play an important role. So IIST Sirpur is the place where trip is being generated or produced, and Avani Mall is a place where trip is being attracted. South City Mall is a place where trip is being attracted. So attractiveness of those areas and the impedance between these areas. So that will influence your trip interchange, TIJ, trip between zone I and zone J. Am I clear up to this? Am I clear up to this?
Yes.
Yes. So now you just look at this flowchart. This flowchart talks about the calibration process of the model. So what we'll do, you just look at the first part of the flowchart. It talks about estimating production and trip generation model. So from trip generation model, what we can do, we can estimate production percent trips or attraction for any zone. So we have estimated production and attraction, and also you see that here in this box we have written target year estimates of interzonal impedance. So interzonal impedance may be different in the target year. Suppose today you have less amount of traffic, so time may be less, but tomorrow when traffic will increase, time may be more. So interzonal impedance may be different tomorrow. So therefore, it is important to have an idea about future impedance that will be there in that place. So once we have such data, impedance between two zones and their production and attraction, what we can do, we can calibrate a trip distribution model, because these values are going to be an input. These values are going to be an input into your trip distribution model. So once you have these inputs ready, you can go for trip distribution model. Once you have developed trip distribution model, as an outcome of that model, what you are going to get? You are going to get target year trip interchange between zone I and zone J. Target year trip interchange between zone I and zone J. Otherwise, what I have told, I have written in this page. I think if you go through it once, you will get to know it in detail. Okay. So now let us move on to the modeling technique. So the modeling technique which we are going to learn here is gravity model. Gravity model, we call it gravity model because this modeling technique is based on the concept of Newton's law of gravitation. And we all understand what Newton's law of gravitation says. It says that force between two masses will be equal to what? The product of the masses and also square of their, inversely proportional to the square of their states. Okay. We are going to apply the same concept in trip distribution while making trip distribution model. In place of M and also in place of M2, in place of M1 and in place of M2, we are going to consider production and attraction. You can see that in place of M1 and in place of M2, we have taken production and attraction. Okay, trip interchange will be there only if there are production of trips and there are attraction of trips. If you don't have production and if you don't have attraction, there are no possibilities of having trip interchange. So the primary condition is what? There must be some amount of trip production, there must be some trip attraction. Then only you can expect trip interchange or trip exchange. And then R is what? Spatial separation. Since in our case, we always do not refer spatial such impedance in terms of distance. Therefore, what we have done, we have expressed it in terms of Wij, which is the impedance, right? Wij is the impedance, and exponent C may be 2, maybe more, or maybe less than 2, because this exponent will depend on the socio-economic characteristics of that area. Okay, it will be different for a residential area, it will be different for commercial area, it will be different for industrial area. So C exponent will depend on the socio-economic characteristics of the area which we are considering. Okay. So now let us look at this diagram. In this diagram, what I have drawn some zones. Okay, so these are zones. Suppose we have some zones in terms of 1, 2, 3 up to X. And here we have another zone I, for which we know the trip production Pi. Okay, so Pi is known. And also we have calculated, based on trip generation model, the attraction for zone 1, attraction for zone 2, attraction for zone 3, and also attraction for any zone X. Right? So now, based on their attractiveness, there will be some trip exchange, based on their attractiveness and also impedance. Based on their attractiveness and impedance, there will be some trip interchange. The trip interchange between zone I and zone 1 will be Ti1. Similarly, next one will be Ti2, Ti3, Tix. Now the point is, if we add them all up, Ti1 to Tix, it will be nothing but Pi. So Pi can be expressed in terms of sum of Tix, right? So if you use equation 1 and equation 2, you get what? You get the constant value K. And now you take this constant in equation 1 and you get equation 4, right? Then what we have done, we have replaced 1 by Wij impedance by something called travel time or friction factor. Okay, so no need to go for separate calibration for this exponent C. Now, if you calibrate it for this friction factor, it will be sufficient. Okay. So therefore, 1 by Wij is replaced by friction factor or travel time factor. So here C is implicit into this Fij. Then what we have done, we have also included socio-economic adjustment factor, because here we have travel time or friction factor we have included, but nowhere we have included socio-economic adjustment factor. So therefore, in the next step, we have introduced socio-economic adjustment factor K. Okay, so K represents socio-economic adjustment factor. So this is the model which we are going to use to solve. This is the model which we are going to use to solve the. Okay. I have given you 2 problems. So now any question after this? You just think on it. If you have 1 or 2 questions, I will take and then I will try to solve that problem. Okay. Okay. So no question. You know, look at your problem. The first one says that a 3-zone city has the following trip produced in and attracted to 3 zones as follows. Okay, so you have data for trip production, TI, and you have data for trip attraction based on your trip generation model. You can see that in zone 1 it is 700, in zone 2 it is 200, in zone 3 it is 0. Okay, and total 900. So you can see that the zone 3 is something, I mean, it is similar to our campus. During morning, there is no production, you have attraction, and it is just the opposite in the evening. Okay. So similarly, you can see trip attracted. In zone 1, it is 0, zone 2 it is 400, and zone 3 is 500. And it is, of course, it must be equal 900. Next one is your impedance factor. Your friction factor based on impedance. So friction factor you have for certain impedance values, and this matrix, OD matrix, shows the impedance that you are going to witness if you travel from zone 1 to zone 1, zone 1 to zone 2, zone 1 to zone 3. For instance, if you travel from zone 1 to zone 3, the impedance which will be offered during the travel is 6. And corresponding to this value 6, your friction factor value is 6. Similarly, if you travel from zone 3 to zone 2, impedance will be 8. Corresponding to 8, your friction factor is 3. Okay. And also you are having the socioeconomic adjustment factor value, which is invariably 1 in your case. Now you need to do what? You need to distribute the trips between the zones. Second problem is quite similar to problem number 1. The only difference is here you don't have this matrix. Instead, you are given these values. If you travel from zone 1 to zone 2 or even from zone 2 to zone 1, it will be 10 minutes. From 2 to 3 or 3 to 2, it will be 15 minutes, and like that. Okay. So here also you have to distribute the trips using gravity model. You can assume any value of Kij since it is not given here. Okay. So you can assume that Kij is equal to 1 even for this problem since it is not given. Okay. So I have prepared a note for this problem 1. Can you see this one? Is it visible?
Yes, sir.
Okay. So this process is iterative, you understand. So you will have to go with some iterations to solve the problem. Let us start with first iteration. First iteration, we can say that m is equal to 1. This is the model which you have developed today. Model to determine trip interchange between zone I and zone J. So it says, the model says that we must know Pi, must know AJ, we must know friction factor between zone I and J, and also we must know socioeconomic adjustment factor between zone I and J. Since we have assumed that socioeconomic adjustment factor Kij is equal to 1, so this part is going to be 1. So we need to have what? We need to have this Pi, AJ, and Hij. Now let us come to the problem. Pi is what? The production for zone 1. Okay. If we are going to determine it for T11, okay. So the first one is for T11. T11 means production for zone 1 and attraction for zone 1. Attraction is 700, attraction is 0. So we have written 700 multiplied by 0. Now we need to determine friction factor between Fi11, sorry, F11. So between 1 to 1, if you travel, your impedance is what? 2. And against 2, your friction factor is what? 10. Against 2, your friction factor is 10. So what you have done here, you have written F11 is equal to 10. 700 multiplied by 0 multiplied by 10. Upon what? You will have to take the sum. Sum of what? Attraction and sum of the product of attraction and this one, friction factor. So attraction for zone 1, attraction for zone 2, attraction for zone 3, that you have to consider. So you can see that attraction for zone 1 is 0, for zone 2 is 400, for zone 3 is 500. 0, 400, 500, and first one was 10. 1, 1, it was 10. Next one will be 1, 2, and then it is 1, 3. So 1, 2, if you travel from 1 to 2, it is 4. So corresponding to 4 impedance, your friction factor is 7. So you can see that here I have written 7. Similarly, if you travel from 1 to 3, it is 6. So corresponding to 6, friction factor is 6. So I have written 6. Ultimately, it's going to be 0. Similarly, I have determined the values for T12, T13, and all up to T33. Okay, you can also make an attempt to determine these values. Okay, you please calculate any of these values, and if you have any problem, please do let me know. And once you have computed these values, you will get what? You will get this OD matrix. Okay, T11 is equal to 0, so against 1, 1 you have written 0. T12 is 338, so T13, 1, 2 is 338, so against 1 and 2 you have written 338. Similarly, it is 362. Okay, this way we have entered all the values whichever we have obtained based on our calculation using gravity model. Okay, now here the interesting part is, if you take the sum of all values along the against row, if you take the sum of all values against each and every row, you will see that these values are exactly equal to what you had in your initial dataset, problem dataset, right? So it is exactly what you had in your initial problem dataset. But if you take the sum of these values against column, it will say that these values are different from what you had in your problem statement, right? So here you can see that these values are 400 and 500, but ultimately you have got something which is different from the given values. Okay. So these values which we have obtained by taking sum along row, we call it production total. And these values which we have obtained by taking sum against each and every column, we will call them as attraction total. So there are two things. So one is production total and the other one is, and attraction total may or may not be same to what we had at the beginning. Okay. So here we'll have to understand the difference, and if the difference is significantly large, in that case we will have to go through a process which is called iterative process. Okay. So you can see in the next line I have written that computed value is 0, 461, 439. So the total is same, but the given values are different. Given values are 0, 400, 500. Okay. So computed trip attractions are not equal to the desired trip attractions. Computed values are not exactly equal to desired. Desired means given. Therefore, further iterations are necessary. So when we go for further iteration, we need to adjust this value. Okay, this is how we will be adjusting the value. Okay, adjusted attraction factor. For every iteration, we will simply follow this expression. And in this expression, you can see there is something called CJ, and CJ is actual attraction. Actual attraction means whatever we have computed. So that is actual attraction. AJ is the desired attraction. So based on this equation, what we'll have to do is one more page. Where is that page? I got it scanned. Okay, please give me a minute. Let me show you the next page. Okay. So now by using that equation, what we have done, we have determined the attraction factor for zone 1, for zone 2, for zone 3. For zone 1, since it is 0, so no adjustment is needed. A1 is equal to 0. For zone 2, simply you consider those inputs. 461 is your CJ here because it is something that you have computed. So this is your corrected value, 347. Similarly, for zone 3, you have 569. So now you are going for the second iteration, m is equal to 2. And in your second iteration, your attraction values are different from what you had considered in your first iteration. In your first iteration, I hope you remember that here instead of 347, you took 400, and instead of 569, you took 500. So now you have considered the revised value that are 347 and 569. Similarly, you are going to consider such values for other trip interchanges as well, like T21, T22, T23, T1, T22, T3. Okay. And again, you develop this OD matrix. Now you can see the production total that is same as before, but attraction total is 401499. And now you can see that computed values 401 and 499 are very close to given value. Given value is 400 and 500, right? So I have written it here. Computed attractions are very close to given attractions. So this process is usually continued until there is a reasonable agreement. Okay, that agreement must be reasonable. Otherwise, we will have to keep on continuing. Okay. So these values, two values, computed values and given values must have reasonable agreement. Okay. Until then, you will have to continue the process. But if you have such problems in your exam, I would advise you to go maximum up to second iteration. So whatever, even if you don't have agreement, you please stop there. Please don't go beyond second iteration in the exam. Okay. Any question? Okay. So shall I conclude here? Are you there? Are you there?
Yes, sir.
Yeah,
Yes,
sir. Yes, sir.
Shall I
Sir,
shall I conclude or you have some questions? I need to upload this one? Problem solved one? I have not uploaded or I want you to give a try. I want to give a try. Or if you want me to upload, I will upload it.
Sir, we will have to stop when that total of that computed attraction is equals to given one.
Sorry.
Sir, we will have to do iteration till that computed attraction total is equals to given one.
When you will say that the given and computed values are very close, when you have reasonable agreement between them, then you will have to stop theoretically. But since, I mean, if you have such problems in exam, I advise you to go maximum up to second iteration. Okay, don't go beyond second iteration. Okay. It is impractical to go beyond second iteration during exam. Okay.
Yes, sir.
Okay. I asked you one question. Do I need to upload this solved one or you would like to give a try?
so we will try.
If you try.
Sir, please upload, sir. If we will have any doubt, we will see from that. We will first try and after that we will see, sir.
See, if you have solved one in front of you, you will never think on it. You know that I have this solved one, so why should I think on it? Anyway, I will upload, and I would request you to give a try for the second one, and also to understand this one, because here I have not calculated all the values, but I would request you to calculate all the values by yourself, so that you get to know how calculations are done. Okay, so I'm going to upload it. And at the same time, I'm requesting you all to solve the second problem by what is your convenient date, because already you have your Rebecca. So I'm not going to give you any deadline as such at this moment. Otherwise, you will be very angry on me. What is your convenient time? Your convenient time will be your deadline. You are again silent.
Sir,
Taking
till
online
Mon-
class
Sir,
is very difficult.
Thursday.
Monday.
Thursday. Oh, so very fine. Thursday. What is your convenient time for class? Last week, no, not last week. We had no plan for you. What is your convenient? I'm going to ask you difficult questions. Okay, think on it and give me time.
Class test theory. Monday.
You wait. I will take your attendance. Or something.
मंडे लिख देंगे।
Class is online. Attendance is offline. So this
Yes, sir.
कब होगा एग्जाम 59 59 Beta, those who are present, you please tell your roll number one by one. Roll number, not enrollment.
63, sir. Sorry, sir. 66.
53, one minute. 63, huh? Simran.
Yes, sir.
Simran,
62, sir.
62. Matal,
Yes, sir.
61.
61. It was true. It's
55.
okay.
66, sorry.
66.
Sir, 92.
Sir, 108.
1 92.
91, sir.
91, 92, 108.
Yes, sir.
108.
Yes, sir.
108.
Sir, 82.
Sir, 90.
90.
96.
96 or 90?
96.
96.
Sir, 101.
99.
89.
59.
No, 96. 96, one by one, please. 96, then 96, then next
Sir, 101.
99.
99. 99. 101.
Yes, sir.
Sir, 90.
89.
59, 90 percent.
That's 98.
98. No, 116. 11. 112.
Sir, 110.
Sir, 98.
110. 1 minute. 98 given.
109, sir.
109. 109. Yes, given.
81.
59, sir.
89 given. Huh? Next, 89. Next,
Sir, 94.
94. 94. Then
100.
59. Puja.
Yes, sir. Yes, sir.
Sir, 100.
100.
Sir, 97.
Sir, 86. Satish Pandey.
But this.
Sir,
Class
roll
roll
number
number.
97.
Class roll number. What is your
86. Sir.
class roll number?
86.
86.
BX class, sir.
86. Yes, next.
Sir, 73.
73.
81. Satya Pratap.
51.
90 है मेरा।
Okay.
Thank you, sir.
So your class test will be on Thursday. Do I have any slot on that day?
Sir, have you marked for roll number 97?
I think so. Right, it is Shoshiram that mark, yes. Satish? Monday.
Yes, sir.
Monday,
Can I
second half.
take your exam on Monday? Monday,
Yes.
second half. Okay, fine. Oh, great. So I will take your exam on Monday, and in that case, I think your deadline for submission maybe Sunday.
Yes, sir.
Okay, so your deadline maybe Sunday. So I'm not writing any deadline as such, but you assume that your deadline for this submission, current submission, is Sunday, and I will take your exam on Monday, the second half, as per our schedule time. Okay.
Okay, sir.
Best of luck.
Submit some marks or copy. And it,
Midterm marks.
yes, sir.
Midterm marks. Okay, I will tell you. I will tell you. You want to know the marks before exam or after exam?
So anytime.
Send better.
No, just tell me before or after.
Before, sir.
Before, sir.
Why? We just would like to flag. If you have obtained 90% in midterm, you will put less efforts for it. If you get 50%, then you will put more effort for exam. Is it like that? Simran?
Yes, sir.
Okay. Okay, I will try to show your answers. I will talk to Professor T.K. Roy. I will try to show it. I think that's possible. Okay.